back to stoichiometry. I can't remember what's coming next. Okay, so I won't draw that out yet. So stoichiometry, grams to moles to moles to grams, is relating amounts of reactants and products through the chemical equation, right? If we have solutions as reactants or products, it's easier to think of them in terms of concentrations and volumes than in terms of masses. And so we can use molarity as a conversion factor at the beginning and or the end of our path here. So instead of grams to moles to grams, we can do a volume of solution A to moles of B to volume of solution B. Or we could have grams at the beginning and volume at the end, or volume at the beginning and grams at the end. There's all kinds of variations. And the beautiful thing about understanding this idea of moles to moles in the middle, and then whatever conversion is necessary to get to that, is you can solve all these problems by learning one technique. So let's do an example. How much 0.125 molar sodium hydroxide solution do we need to completely neutralize 0.225 liters of 0.175 molar sulfuric acid solution? And there's the balanced chemical equation. Here's the balanced chemical equation. Let's use that to organize this information. So 0.125 molar sodium hydroxide. I want to write that under sodium hydroxide in the equation. So what 125, capital M is moles over liters. And then 0.225 liters of sulfuric acid. So 0.225 liters of that guy. And it also gives us the concentration of the sulfuric acid, 175 moles per liter. And then what's the question? How much sodium hydroxide? So question mark. Liters would be a convenient unit. I really need to rewrite these slides. I am sorry. So our normal path was grams to moles to grams. That's what we chant for stoichiometry. But in this problem, we have solutions, right? So this is a solution. We have a volume and a concentration. What we had done before is we had a mass, and we used the molar mass to convert to moles. We've now learned how we can take a volume and use the molarity to convert to moles. So instead of grams at the beginning, we're going to have liters. And then at the end, it's asking how much of this solution, and so that's going to be a volume as well. So we're going to start with this guy that we know about, and this is the one that they're asking us about. So 0.225 liters of sulfuric acid solution. We're going to convert liters to moles. And then what's next? Moles of the other thing, right? I'm getting smaller and smaller, sorry. Moles of sodium hydroxide. And then the last one is liters of that solution, liters of sodium hydroxide solution. Then we're just going to put in previous units so they cancel out. So we want moles of sodium hydroxide down there to cancel those guys. Bless you. And moles of sulfuric acid here to cancel this. What did I do? Ooh, that was scary. It's too much writing to have disappear. And liters of sulfuric acid. That's a mess. The middle term, where I left no room for numbers, those numbers come from the balanced chemical equation, the mole ratio. 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. So 2 moles, and this is 1 down there. Here, what we did when we talked about stoichiometry before is we had to go calculate a molar mass, right? And that was a little tedious at times. Now all we need to do is look at the concentration, the molarity, and just write it down. I think that's a lot easier. I didn't leave room for it, but it's still easier. 0.175 moles per liter of sulfuric acid. And then, at the other end, we need moles of the sodium hydroxide solution per liter. I think this is one of the worst slides I've ever done. So left to right, top to bottom, go across. Turn on the calculator first. 0.225 times 0.175 times 2 divided by 0.125. And my calculator is showing me 0.63. But how many significant figures should I have? 3. My calculator is only showing me 2. What do? Add a 0. So this is a significant 0. My calculator does not understand significant figures. So that would be liters of sodium hydroxide. What you lose when you try to use the dilution equation is you lose the mole ratio in the middle. If it happens to be 1 to 1, it works anyway. And that's why people like to do that. But here, the ratio is 2 to 1. And so if you use that dilution equation, you're going to come up with the wrong answer. Any questions?